Hello, in this video I'm going to show you how to pull down a data file from a server. In this case it'll happen to be an XML file, and then we'll deserialize it and be able to perform link queries on it. So with the weather program we had the XML file locally. With this program we're going to have the data remotely and we'll pull it down and then do the link queries on it. So very similar to earlier activities that we've done, but it's got this twist that now we're getting network connectivity involved. What data is in the file? Well, it's, since it's the end of civilization, I thought I would kind of have a list of stores and what they have in stock and what they don't have in stock. So you can see here the outermost object is a stores, and then each stores has a list of store objects. Each store object has a list of items. Items have a name and a Boolean value that says whether they're in stock or not. So that's a relatively simple document. This is up on the web. I have some hosting space, and here's retroteacher.net/xml/storedata.xml. So you can actually hit this URL yourself and just verify that that data is there. This is the file we are going to pull down. It doesn't have to be a static file. This could be a web page, a dynamic web page that generates a data file for us. So it doesn't have to, it could be any type of URL that we hit, and this thing is just the response that we get from the server. That response could be static content or it could be dynamic content. It doesn't really matter as far as we're concerned. Now, the mappings for this XML document are already created, and I made them using this XML to C# website, which I find to be very useful, and I have zipped these and put these up in Blackboard so you have access to them. In your project, I've added these to my project. So to add them, I right-clicked on the project and said Add Class, and then what that does is makes a new class file for me. I open it up. Then I just clobbered everything out of here, pasted in the mappings, and then that was it. And then changed the namespace to match my program. So now I have this class 1 file in here that I don't need, so I'll delete it. No, class 1 file want to live. Okay, there we go. It's gone. Now, let's just open up that file, and you can see that my program is called shortages, and my namespace is called shortages. So if your namespace or your program is different, just change the namespace and the mappings to match the namespace in your program, and it'll save you a whole lot of time. You won't have to deal with using statements or any of that nonsense. So just make things easy on yourself and just change the namespace in your mapping file to match the namespace in your program, and you'll be happy. All right, let's take a look at the form. The form is very simple. It's a data grid and a combo box. That's it. So, and then I've double-clicked on the combo box to have it generate the handler that gets called when we change select something different in there. Okay. Let's go to the code. What do we need as far as libraries? We need system.xml.serialization. This is for reading in for deserializing our stream from our HTTP request into our C# object. So that's what we need the serialization for. We're going to deserialize some data into some objects, just like we did with the weather data. System.net, that has the network classes in it, so that's got WebRequest and WebResponse that we're going to use. And then system.io is where the info on streams is stored. So the way it works is we're going to make a web request to a URL. We will get a web response back from that, and then get a stream from the web response, and then we can deserialize that into an object hierarchy. I know that sounds complicated, but it's like 5 lines of code. It's really easy. So let's go to our class here, and let's see, what objects are we going to need? Well, we'll need an XML serializer, and I'll call it SCR just for short, and new XML serializer. And then what does it take in its constructor? It takes a type. How do you get the type of an object? And then what type of object do we need? Well, to get the type, use the type of, I don't know what to call that, a macro, or I guess it's a function, but represents it. Okay. It seems more like a built-in macro or something. But now what we want to load our data into is the root of our object hierarchy. That is, if you go to the mapping class, that's this thing, a stores, way down at the bottom, right? This is the stores, contains a list of store, and the store contains items. So this is the root of our object hierarchy. So that's what we're going to deserialize our stuff into. So let's make a store object, or stores, called stores. Oops, no. Our object. Our abject hierarchy. There we go. What else do we need? Let's make a URL for the server that we're going to hit, and the URL is http://retroteacher.net/storedata.xml. That's the file on the server that we're going to pull down. And again, this could be a PHP file, ASP file, anything that generates dynamic content. Did I say PHP? I like PHP. So that's actually all we need. Now, how do we create a web request? Very easy. Web request. Request equals, and here comes the weirdness. You can't make a web request using the new operator. There's a kind of a static factory method built into the web request object. You have to say web request.create. I don't know why, you just do. And then, but that's actually kind of a common pattern when it's building an object that's kind of complicated. And then you can see here that it takes the URI string, basically the URL, what's the target website that you're trying to go to. So put in the URL. We have now kind of created a request that can go to that URL. It's all ready to go to that URL. It hasn't gone there yet. It doesn't go there until we try to get the response. So how do we get a response? Well, if you think a web request makes a request and a web response handles a response, you would be correct. So let's make a web response. Ooh, you know what I saw in there? FTP web request, FTP. So now you can even do stuff with, when somebody clicks, I want to update. Now you can FTP down like the new data files, the new DLLs, all that cool stuff. All right, web response equals. So what does it equal? Well, we have to tell the request to go get the response. Request.getResponse. There you go. So make a request to go to a URL, and then tell that request, hey, go get the response. Go poke that server with a stick and get a response. Don't come back till you have a response. Which brings up an interesting point. If you hit the dot operator, you will see that there's a get response async, which is probably the better thing to call, although because let's say the server is bogged down, or web is slow or whatever, and the way we're doing it will block. It'll halt the program until we get the response back. This is not normally a problem. However, if we didn't want to block our main thread, doing this call asynchronously would be the way to go. However, this gets more complicated because now we're in asynchronous programming. So we're just going to do this the nice, easy way. So just get a response. And then, now that we have our response, we need to get the data out of that response. So let's just look at what's in a response. And you can see that there's an object here or a function called getResponseStream. That lets us read the data back out of the response. All right, getResponseStream. Now, what do we do with this response stream? Let's just call it stream data stream. We'll call it data stream. All right. So now we have a stream. that we can read the data out of that we just got back from the server. What is that? What good does that do us? Well, remember our XML serializer here. It wants a stream. Like when we want to deserialize our data, we need to tell it what kind of sorry, brain fell out of head. So our serializer is going to take a stream and give us back our object. And I can see I forgot to put in here up in type of. I forgot to just put that in there. Okay, so that's the root of our hierarchy. That's the root of the hierarchy we are trying to load the data into. There we go. And then now I can actually do that. So I'm going to load our data into this guy. Equal, wait, where'd he go? Equals SER. There's our deserializer. No, we don't want to serialize. Serialize is going the other way. Serialize is sending the data into the object. Oh look, see there's the IntelliSense says it wants a data stream or a stream. So let's just give it our data stream. And finally, it will complain because if you look at the IntelliSense, the deserialize function returns an object, and this is a stores. So you can't automatically typecast or promote an object to a stores because it just may not be that thing. So we have to typecast it. And we can do this two ways. We could do this like the C++ way, and we could say, so typecast it to a, what am I doing? I forgot. A stores. That would work. Or I could do this kind of the C# way using the as operator. There we go. That's it. So it's like 4 lines of code to hit a server, and well, okay, 5 if you count, you know, that doesn't really count. And you know, we could just take this thing, get response stream, and stuff it right in there, and that would save us a line too. So I don't know. That seems like really cool for just 4 or 5 lines of code. Let's just verify that it works. Oh, but one other thing, since all of this could blow up through no fault of our own, maybe the XML file is bad, maybe the network went down, whatever. Maybe I specified the wrong type of object up here. Let's put a try catch block around all of this. Try. So I just typed the word try and then hit tab twice, and it kind of auto-completed the whole block for me. So try to do this. And for the exception, I'm going to catch the exception by name, and I don't want to rethrow it because then the application will crash. I'm just going to handle it here. And then let me just show ex.message. There you go. So if this fails, it throws an exception, we'll catch it, and then say what the exception was, what caused it, and then that would allow us to go handle it. So let's just run this and see if it works. So I'm going to put a breakpoint there, hit F5 to run this. And okay, so there's our create the request, get the response, read the response, deserialize the response, and then let's look at stores, and you can see, oh look, it's got 4 stores in there, and it's got the date time. Ah, that is so cool. So now that we have this data, we can do link queries on it. So let's populate this guy, the drop down here, with all of the items that we find in our data file. So let's go look at the data file here. This is going to be a little bit tricky because I can't just say select all the items from some collection, because the items are actually all distributed between the stores. So it's like I have to do kind of a double, like a nested loop. I have to say, like, go through all the stores, and for all the stores get the items. And you can do that in LINQ. That's not a big deal. but it's not quite as easy as, like, if we just wanted to get all the stores, that'd be fine because we have one list and that, you know, of all the stores, but we don't have one list of all the items. The items are all kind of broken up and scattered around between the stores. And these names are all the same. You know, every store has the same thing. But let's just assume that, that's not always the case. You know, maybe this store has only 2 things. It says a million things. So what we'll do is we'll kind of look at all of these items and then just select out the distinct ones. And we'll use link for that. So let's get all of the... let me go to the constructor. Okay, so now populate the combo box. Populate the combo box. All right. Link query time. So link query always starts with var result. Because that, well, I mean, you call the result whatever you want. You call it results, I don't know. Var means let the compiler figure out the type. And then from something in collection. So let's say from s in stores dot store. So for all the stores, and then so as we're kind of crawling through the stores, can we do from I in s dot item? That's kind of like a loop inside of a loop. And then let me select the item name. Select I. I don't want to select I because I is like a whole item with like a name and a whether it's in stock or not. And I just want the name. So let's look at the item. We'll get the item's name. You see we had the in stock too. Right, there's the in stock and there's the name. So let's just get the name. Okay, that seems legitimate. Maybe we want to order them by item.name, you know, the ascending. Oh, order by, sorry, order by, one word. And then we don't want like ground beef in there 5 times, right? What we want to do is just take the distinct ones, and in SQL this is the unique keyword. But what we're going to do is put a wrapper around the whole thing and just say, okay, well, select all these things and then just give me the distinct ones. And you can see that there's a distinct function. There you go. So var is going to be a what? Probably an IEnumerable of type string or something. Yeah, so it's going to be an IEnumerable of type string. And now what I can do is I can take this and I can dump it into the combo box. So a combo box it stores all its items in a collection called items, and you can dump an entire array in there. We don't have to dump them in one at a time. Combo box 1 dot items dot, okay, so there's dot add. That would add 1 item, but we can do add range. That's the one we want. Now let's look at what the add range function wants. Add range wants an array of objects. Do we have an array of objects? Well, sort of. We've got results. Results is an IEnumerable of type string. So IEnumerable is an interface. It just means this is some object that implements a list-like interface, but we don't know what the object type actually is. So we can't really just assign or pass in this object as an array because it's not a compatible type. It's looking for an array of objects. We're trying to give it like an object that implements an interface, and we don't know what the type is. However, because C# thinks of this sort of stuff, right? We can just there's a toArray function built into the IEnumerable interface, and that's it. That is it. That'll just dump them all in there. So let's run this and see what happens. Make our request and get our results. And can we see how many things are in there? Results contains, it's hard to see how many things are in there, but let's just step through and see. And there we go. So there's 4 things, there's 4 items, and they showed up in the list. There we go. All right. So cool. So the trick here is that you can kind of do a nested loop like that with the froms. All right, and then let's go work on this selected index changed event handler that we created when I just double clicked on the combo box, and that creates the selected index change right there. So now what we'll do is we'll select, which we're going to find all the stores that have that item in stock. And again, this is going to need some sort of nested, kind of from structure like that, because we have to go through all the stores and then get all the items from every store. It's not like we have one giant list of items. We've got sort of several small lists of items. And actually, why don't I just kind of I'll just start with that. I'll just copy and paste that. Okay, so okay, so let's do the same thing. Var results equals, okay, crawl through all the stores. As you're crawling through the store, call each store S, and then for every store S, you're going to kind of do this inner loop. And what do we want to do in our inner loop? Well, we need to check if the item name matches the whatever's selected in the combo box. So whatever they've selected here, that has to match, because like if we select hand sanitizer here, we just want to see hand sanitizer here. And we only want to see it if it's in stock. So if a store doesn't have it, we don't want to see it. So we're going to do 2 filters, 2 where clauses. We'll say where, let's see, i.inStock, ooh, look at that, equals true. And, or is it the double ampersand? I always forget. Oh no, there's no anything. Where what am I looking at? Sorry. Oh right. And the name of the item has to match whatever's in the combo box. So if the item's name is equal to, okay, how do we get the name out of the combo box? Well, let's look at the combo box and see what's in there. So the combo box has this name, no, selected something, selected index, selected item. Selected text is not what actually we want, even though that seems like it would be. But really what we want is selected item. That is the object that is currently selected. However, this is an object and this is a string. So let's use the toString function on the thing in the combo box. So does the string that was selected match the name of that item? And then finally, now we can actually throw it in the result set using the select. So it's like, so there you go, from up top, select at the bottom. So it's really like an upside down SQL query. And then what do we want in the result set? Maybe the name of the store, the name of the item, and just confirmation that it is in stock. So let's make a new object that's a combination of all of these fields. So let's see, the store, we may end up with one of these name collisions because the store has a name and the item has a name. So let's call this thing store name. Well, let me just show you what the problem is. Our store is called S and our item is called I, and they both have a name property. So I can't really select store.name, s.name, and item.name because now the resulting object has 2 name properties. So I can rename them by making a new kind of column or new property. Store name, I'll just call it store name. And let's name our item, call this item name equals. And now we've kind of renamed the store's name to be store name and the item's name to be item name. And then let's also just throw in I dot in stock. And we're just missing the semicolon on the end. And there we are. Or let me move that off to the side. There we go. So that's our result set. So go through all the stores. For each store, go through its items. If the item's in stock and the item's name matches what's in the combo box, then create a new item or create a new object with the store's name, the item's name, and the variable that says whether it's in stock or not. And then that's all going to end up in results. And if you hover over results, it says it's A is a string store. Right? You know, now it's like the type starts getting kind of complicated. So that's what var is for. Now that we have this, we can throw it in our data grid. Data grid view 1 dot data source equals. Now let's look at the data source. It takes the data source takes what? Well, it says it takes an object. Now the interesting thing is results is not an object. It's an interface. So we have to convert it to a list or an array. So let's try that. Results dot. Let's try toList. All right. And let's run that. F5. Get the data and hand sanitizer. Oh, look. Oh, I guess I didn't make it wide enough, but yes. So there's our stores. That's going to bother me. Let me make it just a little bit bigger. There we go. So you can see that it's showing us who's got what. So that's it. I mean, not a super sophisticated interface. I mean, we could make it a lot more useful, I guess, if we wanted to, or more. But yeah, I mean, the whole point is this right here. This web request, web response, deserialized. 4 lines of code. Allows you to just grab whatever you want from any server in the world, pretty much. And then once you have it, then you can do stuff with it, writing link queries, which hopefully are getting a little bit more intuitive. I know that the syntax is just kind of awkward if you're not used to using SQL. And even if you have used SQL, link is a little awkward because it's kind of like SQL but upside down. But once you kind of get used to it, like this is a lot more elegant than having, writing like traditional nested loops. It's a lot cleaner, a lot more elegant. So there you go. I mean, not a super complicated program, but again, we hit some pretty cool topics. I mean, here we had the name collision in the field and the fact that we had to do two from clauses to kind of do a loop inside of a loop. So I don't know, cool stuff. Hope you found it useful. I think, once you get the syntax, the basic syntax down, you can just kind of Google stuff and go on MSDN, the Microsoft's documentation site, and then there's so many features in the language that are just really make it very, very powerful. And I just can't really. It's really my go-to language for any kind of heavyweight project, and I can't really see using any other language. And that's as a guy who spent a lot of time using Java and C++. So it's a great language, a huge set of features, and it's very, very well designed. So and then we also got some exception handling in here, right? So again, this blows up. Don't let the application crash. Catch the exception and report it. All right, well, that was it. Hope you found that to be kind of useful, eye-opening, a lot of possibilities there, just a lot of great features built into the language.